Hi and welcome back. So this time I'm going to do another video for you. It will be about the Docker submission process in track number 1 of the MIDOG 2025 challenge. Okay, let's get this started. Let me first reiterate the evolution of MIDOG. In 2021, we started with generation to unseen scanners. Then, in 2022, we continued to generalize to unseen tumor types and lab environments. However, we always used pre-selected regions from the dense tumor area, which we cannot expect to generalize to an application for whole slide images. This is why, for this iteration of the challenge, we took the investigation of generalization one step further. We have 3 different selections of regions in this iteration of the challenge. First, in the test set, we now not only have 10, but 12 domains. Yet, the big extension of the datasets comes from not only having 2 square millimeter regions of the hotspot area of the tumor, but also from challenging and random regions, as you can see here. We included challenging regions such as regions containing necrosis or inflammation, since these are prone to having hard negatives, cells that look similar to mitotic figures but are actually not. And finally, we also cover random tissue selections in an attempt to statistically generalize to whole slide application. This is how the Docker submission process works. You first have to build your inference pipeline like you would for any other machine learning tasks. Then you have to embed it into the Dockerized pipeline, which we provide, meeting specific input and output format requirements. Finally, you upload the Docker container to Grand Challenge for evaluation on the test set. The task of your container will be to run inference on a single image in task 1, spanning approximately 7,000 by 5,000 pixels or so, depending a little bit on the resolution. It will be always 2 square millimeters. It will have to provide a prediction output, your container, in JSON format. Now, Grand Challenge will run the containers many times in order to actually acquire the results on all images. Finally, an evaluation container is being run on the results and also on the ground truth to calculate the metrics of our challenge. Let's now come to the expected output format of a single container. As you can see here, each detection results in an independent entry in a list in JSON format embedded as so-called points key of the main dictionary. For each point, we require the X and Y coordinate in millimeters. Make sure this is not in pixels, it's in millimeters. There is another entry in the list, which is the Z coordinate, which is obviously always 0 as we're talking about single plane images. Then, for each detection, you need to give the probability of being a mitotic figure. This is necessary for the calculation of threshold-less metrics such as average position. And finally, you have to give the decision whether this is a mitotic figure, which typically means it had a probability above your optimized threshold or not. If it is, so if your method decides it is a mitotic figure actually, so it's above threshold, then you give it the class mitotic figure, else it needs to be a non-mitotic figure. Now I want to have a word about our datasets. We have 2 datasets, a preliminary evaluation set meant for technical validation. This dataset does not include random or challenging regions, and a single run per team and day is allowed to check your methods on this dataset. Do not try to circumvent this restriction, it will lead to disqualification in the challenge. The final challenge set is much larger, including 365 images, and only a single shot on it is allowed. You need to run your containers on the preliminary evaluation set to check for technical function before being allowed to submit on the actual challenge test set. Now, one thing that is really important here is that those 2 datasets have different statistical properties. This means in turn that it is not meant for optimizing the algorithms on the preliminary evaluation set. So People did this in the past. In previous editions of the challenge, they iteratively tried to optimize their results on the preliminary evaluation set by kind of daily submissions, and it ultimately did not work out as they over-optimized on the characteristics of the preliminary evaluation set. So be smart and don't do this. It's really just meant for technical checking. Now, if you want to submit, then we provide a template, and the template includes our reference algorithm as an example. For track number 1, this was provided by Jonas Amling from my group, and it's based on his well-done inference pipeline for mitosis using the FCOS architecture with the ResNext 101 backbone. The training was done on the MIDOG++ dataset, which is an extension of the MIDOG 22 training set that we released in 2023. You can find this, including a step-by-step guide on how to submit the in the GitHub repository on this slide. Also, you will find the GitHub repository link, of course, here in the video description. There is another thing that we need to highlight, as some of the challenge participants have not yet had their account validated. So validating your account on Grand Challenge is a requirement. It's a required step before you can submit to the challenge. Please make sure that you do this in a timely manner, as it might take some days due to manual checking being involved, especially if you don't come from an educational email address. Now, this is the Docker submission workflow in a nutshell. You have to embed your algorithm into the container following our template. Then you have to create an algorithm entry on Grand Challenge. If you do that, the next step is to, if you did that, the next step is to upload the tar.gz file, that's the container, to that algorithm entry. And if everything succeeded, after some time the platform needs for importing the container, you will be able to test the package. Make sure that you do the testing on some example images before submitting to the preliminary evaluation track of the challenge, and then of course also later to the final track of the challenge. Another thing that is worth mentioning is that we require a short paper detailing your algorithmic work with the final submission. So if you want to submit to the challenge and become part of our workshop, and also to become that submission part of the proceedings, then you will need to provide a short paper. We will provide a template for that in a timely manner. So it is worth noting that this needs to be on a publicly available preprint server. We do not accept private file hosting such as Google Drive or your own website for that matter, as it does not ensure long-term availability of the paper. Right, I would say that's it. I hope this covered everything you need to know for now. If not, please reach out to us. The easiest way of doing this is finding us on the Discord server. The link is also provided down in the video description. Okay, so long. Have fun in the challenge and see you there.